Hey everybody, I know you guys were struggling with some of the conversions for the case study for tuna for lunch, so I just wanted to kind of walk you through it a little bit, and then you guys can do the last conversion on your own. But basically, what you need to do is you need to look at table 2, all right? So it gives you a whole bunch of things here. It gives you the mean, median, standard deviation, minimum, maximum, and the number of samples they did, and then here are the units. All right, so the things that you need to do in order to do this conversion is know what the units are, right? And you're going to take the mean in order to figure it out. All right, so it gives you the mean for your fish, sediment, and water. All right, so it looks at first glance like sediment is the highest because it has the highest number, right? However, if you look at the units, they're not all in the same units. Anytime you're comparing anything, you have to make sure that all of your units are the same. If they're not the same, you can't compare them to one another. Okay, so what you have to do is try to figure out which unit you would like to convert all of them to. Now, if you look at the units that they give you, you have micrograms per grams, nanograms per grams, and then nanograms per liters, right? If you look at all of those units, there's one that is easier to do than the others just based on what it is. So you have your nanograms per grams, you have grams here, and you have nanograms here. So because of that, you only have to do one conversion for each if you pick this one, right? Because you already have nanograms here and you already have grams here, so you only have to do one. So I would recommend doing that one because it's going to be a lot easier than the other two. Okay, so when you're converting, what you have to do is start with what you have. So for fish, right? For fish, you have 0.261 micrograms over technically 1 gram if this were math. Right? So that's what you have for your fish. Okay, so we're trying to go from micrograms and grams to nanograms per grams, right? So what you have to do, right, is you're going to do some dimensional analysis, or you're going to work with some fractions. Okay, so when you're doing micrograms per grams, we're trying to go to nanograms, right? Your grams you already have. You're trying to get to nanograms. So what you have to do is figure out how many nanograms are in a microgram, right? And since your micrograms are on the top, you have to put the micrograms on the bottom on this side. Okay? That way, when you finish the conversion, then you can just cancel out your units. Right? And I'll show you that again at the end. So you have 0.261 micrograms per grams, right? And you need to get to nanograms, so you're going to put your nanograms on the top. So what you have to do is look at the page before on the case study and see how many nanograms are in a microgram. If you were to look at it and work with the decimal places, you would find out that there are 1,000 nanograms in 1 microgram. Right? So since you have 1,000 nanograms in 1 microgram, then you would convert it like this. Since we cancel out the micrograms here, the units that are left are my grams and my nanograms, right? Which is actually what I'm trying to convert it to. So then, if I were to do the math, you would come up with 261 nanograms per gram, right? The 1 stays, because you would multiply your 261 by your 1,000, right? Which would make me move my decimal places 3 places to the right. 1, 2, 3, right? And I would end up with 261 nanograms per gram, right? Because of that, that now changes my number, right? So if you remember at the beginning, we had 1.65 nanograms per gram of sediment. This was our sediment, right? And now for fish, I have 261 nanograms per gram. right? So at the beginning, what we thought was, oh, I'm sorry, you can't see that. Right, at the beginning, we thought sediment was the highest, right? Because it had 1.65 and the fish had 0.261, right? So we thought that was smaller. Now, if you compare them in the correct units, you realize that fish is much higher than sediment, right? So now your answer completely changes because we finally took the units and put them in the correct units, right? That's why converting is super important, because what appears to look smaller is actually bigger if you were to put them in the same units. It's all based on what the units are. All right, so for the final one, being water, all right, when you do water, you're going to have to do the same thing, but you're going to have to convert your liters now. So you're going to have, let me show it to you, set it up. All right, so for water, you're going to have 0.19 nanograms per liter, right? And you need to get to nanograms per grams. So the nanograms is going to stay this time rather than changing that. So you're going to have your nanograms over your liters, right? So then where do you think I need to put my liters? On the top or on the bottom of this equation? You're going to put the liters on the top, right? Because if you put the liters on the top, now you can cancel it out. If I put it on the bottom, right, they're on the same level. You can't cancel them out based on fraction principles. So now that I have my liters here, right, then I'm going to have 1 liter, and I'm going to have the amount of grams on the bottom, because this is what I'm trying to get to, right? I'm trying to get nanograms over grams. So you put your grams on the bottom. So what you have to figure out is how many grams are in 1 liter, right? You're going to put that here, and then you're going to solve again. The liters are going to cancel. You're going to be left with nanograms over grams, and then you're going to be left with a number, right? So then it's going to come to nanograms over grams, and then you're going to have a number here and here, and then you're going to have to compare this number, right, for water to your numbers for fish and sediment to see which one is the highest. Now, once you get that answer, then what number 7 is asking you to do is, why do you think that is? All right, so why do you think the one that you found is the highest above the other two? And for that, you're going to have to use the other video on biomagnification and bioaccumulation to give your reasoning for that. All right, I hope this makes sense. If not, send me an email. We can meet on Google Meet, and I can help you out with that. All right, thanks. Bye.